Okay, so we are starting with the first question. So with the first question, I read: a baker has 150 kilograms of flour, 22 kilos of sugar, and 27.5 kilos of butter, with which to make two types of cake. Suppose that making 1 dozen A cake requires 3 kilos of flour, 1 kilo of sugar, and 1 kilo of butter, whereas making 1 dozen B cake requires 6 kilos of flour, 0.5 kilos of sugar, and 1 kilo of butter. Suppose that the profit from 1 dozen A cake is 20 and from 1 dozen B cake is 30. How many dozen A cakes and how many dozen B cakes will maximize the baker's profits? I'll try as much as possible to attach the question to the video as well, so that you'll be able to get the calculations we are going to do it. But for now, I would read it and put down the necessary information we need. But I would attach a picture of the question in the video so that you'll be able to grab the concept very well. So now let's go over again. A baker has 150 kilograms of flour. So with flour, we have 150 kg, 22 kilos of sugar. So with sugar we have 22 kilos, and butter we have 27.5 kilos. Butter 27.5 kilos. So that's the beginning of the question, the information we have now. Flour has 150 kilograms of flour has 150 kilos. Sugar was given as 22 kilos. Butter was given as what? 27.5 kilos. Okay. So now we are saying that suppose that making 1 dozen A cake. So we have dozen A cake. So dozen A cake. Dozen A cake. Okay. Suppose that making 1 dozen A cake requires 3 kilos of flour. So meaning that with dozen A cake, we have with flour, we have 3. Then that same a cake requires, suppose that making 1 dozen A cake, it requires 3 kilos of flour. So with dozen A flour, we were given 3 kilos. Then with sugar we were given 1 kilo. Then also with butter we were also given 1 kilo. So butter 1 kilo. Now continue. We are saying that whereas making 1 dozen B cake, so dozen B cake, so with dozen B cake too, flour is 6. With flour we're giving 6 kilos. Now with sugar we're giving 0.5. With butter we're giving 1 kilo butter. Now suppose that the profit from 1 dozen A cake is 20 and from 1 dozen B cake is 30. So the profit dozen A was given as 20. So suppose that the profit from 1 dozen A cake is 20 and from 1 dozen B cake is 30. So profit from dozen B cake is 30. Now, how many dozen A cakes and how many dozen B cake? How many dozen A cakes, which is X, and how many dozen B cake, which is Y, will maximize the baker's profits. So now, take note. The information the question is giving us, we are going to maximize profits at the end. So meaning that at the end of this question, our concept is we want to maximize the baker's profit. So as I was explaining the theoretical part, that we have minimum and we have maximum. And with minimum it's less than, but in the question we use what's greater than. If it's maximum, maximum means greater than, but in the question we use less than. So with this particular question was indicated that it was what? Maximize or maximize or what? Maximum. Okay. So how many dozen A cakes, which is X, and how many dozen B cakes, which is Y, will maximize the baker's what? Profit. So we want to know the number of cakes. The number of cakes that will maximize dozen A, a number of cakes that will maximize dozen B. So this is all what we want finally. But per the question, we are saying that let's represent dozen A cake by an X, and let's represent dozen B cake by a Y. That was what the question indicated for us. So this is the concept. We're saying that to a baker, for a baker to deal with cake or to deal with the production of cake, a baker has 150 kilos of what? Flour, and 22 kilos of what? Sugar, and also have 27.5 kilos of what? Butter. Now, per the question, the baker is producing two types of cake. One is dozen A cake and one is dozen B cake. And per the question, we're told to represent dozen A by an X and dozen B by a Y. So producing dozen A cake, we have three ingredients here. One is flour, one is sugar, one is butter. So for me to produce dozen A cake, I will need 3 for flour. I would need 1 kilo for sugar. I will need 1 kilo for what? Butter. Now, producing the next type of cake, which is dozen B cake, I will need 6 kilos of what? Flour, 0.5 for sugar, 1 for butter. It was stated that for me to get a profit, dozen A was given 20 and dozen B was given 30. And the info in the question, or the question demands that we should use what? We should find the maximum profit, or we should find the values of dozen A cake and the value of dozen B cake that would maximize profit. So now it's either in the question you'll be given minimum or maximize, but with this particular question you have what? Maximize, not minimum. So we maximize, we know the correct thing is maximize means greater than. But per the concept, when we are solving maximize with respect to linear program, rather use what? Less than. That is just the overview. So I want us to get this information. So we have flour 150, sugar 22 kg, butter 27.5 kg. So with this information we have here, we are going to present them in a table form. So what I'm going to do for the meantime is I'm going to clean this particular side for us to form the equations. Okay. So that is what we do. Now, flour, we have 150 kg, sugar 22, butter 27.5. Now, one trick about this question is sometimes you find it difficult to know the values to bring at the vertical side, which is the side, and also to know the values to bring at the horizontal side. But with this, there are various tricks we use. So what I'm going to teach you guys is whenever you want to form the table for the linear programming question. Now, when you read a particular question, you notice that certain commodity or certain products are given their total. So what I mean is, with flour, the total is what? 150. Butter, the total that was given was 27.5. Sugar, the total that was given was what? 22 kg. So the products or the commodities with the totals are represented at the vertical side. What I mean is, so for instance, the first one given, I was given flour here. So this is flour. I was given butter. This is my butter. I was given, from flour we were given sugar. From sugar we were given butter. Okay, so that's where the ingredients or the commodities in question. We have flour, we have sugar, we have butter. Another trick is, once you are done bringing the commodities that have their total at the vertical side, make sure that the commodities corresponds with their total values. So for instance, with flour, we were given a total of 150. So this is 150. Sugar, I was given a total of 22. So this is 22. Butter, I was given a total of 27.5. So this is 27.5. Once you are done with this, now let's check out from the question. What were we asked to finally solve for? They said we should find for the number of dozen A cakes and the number of dozen B cakes that would maximize what? Profit. So once we have the ingredients or the commodities that have their corresponding totals here, the next thing we do is we bring what we are finding for in the table. So for instance, we have dozen A cake. So I come to the side. I just put dozen A cake. It was represented by an X. It was stated in the question. Then I have dozen B cake. It was represented by a Y. So the next thing we do is, now when you come to dozen A cake, they were given various numbers for flour, various number for sugar, and that of butter. Same applies to dozen B. So let's come to the question. With dozen A cake, what number was given for flour? So with dozen A cake, they gave 3 for flour. So this is 3. By which variable are we using? X. So 3x. With that same flour for dozen B, what number was given for flour? We're given 6. Dozen B is represented by what? A Y. Now let's come to sugar. With sugar, for dozen A, what number was given? We're given 1. So it's just an X. We don't have 1x. It makes sense though, but most say just an X. Then that same sugar, let's come to dozen Y or dozen B cake. Sugar was given as 0.5. So 0.5Y. So now let's come to butter for dozen A cake. So butter for dozen A cake was 1. So it's just an X. Let's come to that same butter, but for dozen what? B cake. It was given as 1. So it's also a Y. So this is how we form our linear programming table. So what we finally do is, you now check the question, were we given minimize or maximize? In the question it was stated that what? Maximize profit. So you just put the maximize here. So this is how we form the linear programming table. Now, in this same question, we were told that we should give a profit of 20 to dozen A cake and we should give a profit of 30 to what? Dozen B cake. So we would have to form our what? Profit function. So to get the profit function, now with the profit function, we know it. F is equal to AX plus BY. So now to form the profits, it's maximized. And I indicated that with maximize, we use the profit sign or we use a Z. But we minimize, we use a C. So since we are using maximize here, we can decide to use the profit sign or a Z. So I'm just using the profit sign. So they said we were given 20 for what? A profit of 20. Profit of 20 for dozen A. And a profit of 30 for dozen B. So with dozen A, they told us represented by an X. Dozen B represented by what? A Y. So meaning a profit for dozen A cake, which is 20. We know 20 represented is by an X, so it's 20X. With dozen B, we were given a profit of 30. And dozen B was represented by what? A Y. So meaning the profit function or the objective function for this particular question is given as this. So this is our profit function or our objective function. So profit is equal to 20x plus 30y. So this is how we solve for the linear programming table, and this is how we get our objective function or our profit function. So the next thing we'll do is we are supposed to use this information, what is in the table, to form what we call the constraint or the subject. So I'm going to clean the top side. Okay, so we move to the constraint. Or the subject. Now, for you to get the constraint or the subject, we form them from our table. So what we'll do is I'll first pick flour and find for the constraint for flour. When I'm done, I'll also do that for sugar and also do that for what? Butter. So I have flour. Okay. So with flour, this is flour. So to get the equation for flour, this is what we have. We have 3x plus 6y. 6y. Since we are using maximize, I explained earlier on that if it's maximized, the actual meaning we all know is greater than. But per linear programming, it's rather what? Less than or equal to. So less than or equal to. Then we bring the number here. The total for flour was 150. So we are forming the constraint. So now we move on to the next constraint, which is sugar. So we have sugar here. So with sugar 2, it was x plus 0.5y plus 0.5y less than or equal to 22. Then the next one is we have butter. With butter 2, we have x plus y less than or equal to 27.5. So one would ask, where are we getting this concept from? We are getting this concept from the understanding of maximize. Maximize in the normal world, the normal perception, or the normal understanding is greater than. By linear programming, we rather use what? Less than or equal. That's why you see this thing running through here. Okay, so this is how we form our constraint, or what we call the subject. So this is the constraint for flour, this is for sugar, this is for butter. So what we are going to do next is we will pick them one by one and find for x and find for y. So assuming I pick flour, I'll find for the values of x for flour, find for the values of y for flour, do the same for sugar, and also do the same for butter. When I'm done, I will now use them in a diagram form. So the diagram would help me to get what? My maximum profit. So I'm cleaning this down part. Okay, so I'm going to form the constraint for flour. So I have flour here. So flour, if I have 3x plus 6y less than or equal to 150. Now, since we are going to find for x and also find for y, we don't maintain the linear equality symbol. The linear inequality symbol, we don't maintain it. So since you are going to find x and y, you need to change this to equal to. So we now use this. So this is 3x plus 6y is equal to 150. If you want to find y, make x 0. If you want to find x, make y 0. So now I'm finding x, so I'll make y 0. So when y is 0, so I have 3x plus 6, y is 0, this is 150, this gives me 3x, this is 0, so it's equal to 150, this is over 3, so x is equal to, so 150 divided by 3 would give me 50. So I have 50 here. So this is when y is 0. So I'll do another one when x is also 0. So I have 3, x is 0 plus 6y is equal to 150. Remember that we are finding for coordinates, so we need to change the inequality sign to an equal to, because we want coordinates. So now when x is 0, so on either side I have 6y is equal to 150. I want y, so 6. There's also 6. This moves here. Y is equal to 150 divided by 6, which is 25. So y is 25. So now let's form the coordinates. Now we know that per our Cartesian plane, this is y, this is x. So always in forming coordinates, we have x, y. So x comes first before the y. So let's form the coordinates for this side. So when x is 50, y is 0. When x is 0, y is 25. So this is how we form the coordinates for flour. So when x is 50, y is 0. When x is 0, y is 25. So we are done for the coordinates for flour. There is it. So we now do the same approach for sugar as well. So I'll clean it. So you move to sugar. Okay. So with the sugar 2, I have x plus 0.5y less than or equal to 22. Since we are finding for coordinate, we change it to x plus 0.5y. We change this to an equal to 22. So now I'm starting. When x is 0, so this is 0, this is 0.5y, this is 22. So now 0.5y equals 22. We divided both sides by the coefficient of y, which is 0.5. So this is 0.5. You have this. So y is equal to 22 divided by 0.5, which is giving us 44. So we have 44 here. So now let's find the points where x is 0, y is 44. So here we started by making x 0. So now when y is 0, so we have x plus 0.5y is equal to 22. So when y is 0, so x plus 0.5, y is what? 0. And this is 22. So this gives us 0. So x is equal to 22. So when x is 22, x comes first. When x is 22, y is 0. So these are the coordinates we are also going to get for sugar. Where x is 0, y is 44. Where x is 22, y is also 0. So we are done with the sugar as well. So we now move to the butter. After we are done with the butter, then we use our coordinates to plot a graph. That's all the concepts. Once you have the graph, we'll be able to detect our maximum point from the graph. When we get to that side, I will explain it. So now we move on with butter. So we have butter. With butter 2, we have x plus y less than or equal to 27.5. So we change it to an equation. It's equal to 27.5. So when x is 0, so this is 0 plus this is y, this is 27.5. So where y is equal to 27.5. So to form the point where x is 0, y is 27.5. So now we are done with x. So when y is also what? 0. So I have x plus y is equal to 27.5. So x plus 0 is equal to 27.5. So when x is equal to 27.5, so where x is 27.5, y is 0. So these are the points we are also getting for butter. So now we have all the points for flour, we have all for sugar, we also have all for what? Butter. So the next thing we'll do is we move straight in sketching the diagram. Okay, so since we have the information here, we have flour to flour, these are their coordinates. With sugar too, these are their coordinates. With butter, these are their coordinates as well. So since you have the coordinates now, we would have to sketch a diagram by using this coordinate. So we have this. So this is the x-axis. This is our y-axis. So check through. X side 0, 0, 0, 50, 22, 27.5. Then we pick a scale. So let me use 5 centimeters to 2 units on both axes, because with the y to 25, 44, 27. So yes, I think it would work out. So this is 0. This is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Then with this side too, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I'm starting with the flour first. So where x is 0, y is 25. Where x is 0, y is 25. There's it. So I'm done with this. Where x is 50, y is 0. Where x is 50, this is 50, y is 0. So the next thing we'll do is we'll join the coordinates together to get a line, a straight line. So we have this. So this is for flour. Once you are done with this, you would have to introduce its inequality equation on the line. So let me check what was its inequality equation. It was 3x plus sy. 3x plus sy is less than or equal to 150. So I'm representing flour by an f. So it was 3x plus 6y less than or equal to 150. So we move to sugar. So we are done with flour. We move to sugar. So with sugar, where x is 0, where x is 0, y is 44. So this is 45. So 44 will be somewhere here. So where x is 22, y is 0. Where x, this is 20, so 22 will be somewhere here. Where x is 22, y is 0. So we'll join it as well. Yes. So with sugar 2, we will also come and fix its inequality equation on the line. So with sugar 2 was x plus 0.5. So I'm representing it by an x. It was x plus 0.5y less than or equal to 22. So you move on to the last one, butter. With butter to where x is 0. Where x is 0, y is 27.5. So this is 25. So 27.5 will be somewhere here. The next one, where x is 27.5, y is 0. Where x is 27.5, so somewhere here, y is 0. So we join it. So we just want to put its inequality equation on its line. So this one was butter, so it was a b. It was x plus y less than or equal to 25. X plus y less than or equal to 27.5. 27.5. So this is how we use our coordinates in sketching what our diagram. So this is how we do it. So once you are done with this diagram, the next criteria we take into consideration is you need to identify a particular point or a particular shape where two or more curves are meeting. What I'm saying is we have sugar, we have flour, we have butter. You need to find a particular point where two of them, whether sugar or flour or butter, where they are meeting, but they are meeting within a given shape. Now take note, the question was using what? Maximize. And we maximize, I indicated earlier on in the notes that we maximize, we use less than or equal to. So one trick in getting to know the admissible region or the feasible region, once you're done with the diagram, we identify a particular point where we call the admissible region or the feasible region. Where the admissible region or the feasible region is supposed to form within a given shape. So the trick is, when you are dealing with maximum, it's saying that what? Less than or equal to. So meaning that for you to get the maximum or the feasible region for a question with maximize or maximum, it's supposed to be below. So for instance, the feasible or the admissible region will be at this point. So this is the admissible or feasible region. if it's maximized, the admissible or the feasible region it's here. It's below. So this is where it's supposed to be. But assuming the question was using minimize, the admissible or the feasible region would be at the outer line, would be here. If it was minimum or minimize, it would have been here. But since it's using maximize and it's saying it should be below, so this is where the admissible or the feasible region is going to be. That's the concept. So after you've identified the admissible or the feasible region, the next thing we'll do is you are supposed to find a point where two of the commodity or products are meeting, but they are meeting within this admissible or feasible region. So for instance, with this side, let me name it an A. Now you could see there's also a point here, but this point is not meeting within the shape. So we don't pick this point, we pick this side. Now let's continue. I'll pick this side as a B. This side is meeting within the admissible or the feasible region. Now I'll pick this side as a C and also pick this side as a D. So one would ask, why are we not picking this particular point? Why are we not picking this side? I'm not picking this point because it's not meeting within the admissible or the feasible. As you can see, it's meeting outside this. So we don't pick this point. But the C is meeting within the shape. D is meeting within the shape. The top of the D, which is the side, it's not meeting here. So we don't pick that. That's how we do it. So now, since we've identified our corner points within the admissible or the feasible region, the next thing we'll do is we are supposed to pick our corner point. So I start here. So corner point. So in my corner point, I start with A. So with A, X is 22. Y is 0. I move to B. So this is B. You move it like this. You move this 1, 2. So let's say where X is 16, Y is, let's say 12. So you move to C. This is C. Where X is 5, Y is, let's say 22. Y is 22. Let's move to the D. With D, where X is 0, Y is 25. So that's all. You can decide to put an alphabet and F for something, but most of the times we ignore it because this side will give you 0, 0. You can decide to bring it, you can't eliminate it. But most of the time, those ones are the important ones. So I guess I've explained the main reason why we are not picking this point as a coordinate. Sorry, we are not picking this point as a corner point. We are also not picking this point as a corner point. We are not picking this ones. We are not picking this ones because they are all not meeting within the shape. So we don't pick it. But the ones I labeled as the A, B, C, D, the ones I labeled as the alphabet, they are meeting within the shape. That's why I picked them as what? My corner points. But those ones are not meeting within, so we don't pick. Now, so this is the concept for maximum because everything is below. So with maximum, the feasible, the admissible region is within the shape, this side. But assuming the question was minimized or minimum or economically, the admissible or the feasible region will be outside. So get the tricks, get the difference. Maximum it forms here, with minimum it forms outside. That's all. That's the simple trick. That's how we do it. So now, since we now have the corner points, we are going to use this corner points to determine our maximum profit, because the question stated that find the values of X and Y that would maximize profit. We want to find the values of X that would maximize those A cake, Also find the value of y that would maximize dozen B cake. So this is what we do. Since we have our corner points here, sorry, my marker is a bit disturbing. So since we have our corner points here, with this particular point is where we are supposed to have our profit function. Remember, from the beginning of the calculation, we got a profit function of 20x plus 30y. So we want to find our maximum profit. So remember, this is 20, so this is 20. The x, you come and pick the x value here, so x here is 22. This is plus, this is 30, you come and pick the y value here, which is 0. So 20 again, the profit, x is 16. Plus this is 30, y here is 12. You pick the 20 again, x here is 5. Plus you pick the 30 here again, y here is 22. You pick 20, x is 0, plus 30, y is 25. So we now use our calculator to get the answers. 20 times 22 plus 30 times 0. The first one will give us 440. The next one, 20 times 16 plus 30 times 22 would give us, 30 times 12 would give us 68. Sorry, it's 12, not 22. So with this side too, 20 times 5 plus 30 times 22 would give us 760. Then the last one, 20 times 0 plus 30 times 25 would give me 750. So we have this. So for the corner point A, the maximum profit is 440. For the corner point B, the maximum profit is 680. For the corner point C, the maximum profit is 760. For the corner point D, the maximum profit is what? 750. And the question is saying that let's find for the profit of, let's find for the profit that would maximize dozen A cake and that of dozen B cake. So we want to know the value or the number that is going to maximize dozen A cake, which is X, and dozen B cake, which is Y. So since the question is dealing with maximize, per the inscriptions of the diagram, that is where we use the concept of the less than or equal, because everything is supposed to be in this given side. But in determining the maximum profit, you come to the final answers column, this particular column. Then you check the bigger number there or the bigger value there. So you check, we have 440, we have 680, we have 760, we have 750. So you check which one is the bigger one. So let's check. I think 760 is the bigger one. But remember that per the question we asked to identify the number of dozen A cake and dozen B cake, which will maximize the baker's profit. And remember we indicated or denoted dozen A cake by an X and dozen B cake by what? A Y. So since we've identified our maximum profit to be 760, we would have to find the number that will maximize X, dozen A, and the number that will maximize Y, dozen B. So where the 760 is, you match it to its corner point. So this side. So the maximum profit is 760, but I want to know the number that is going to maximize X, the number that is going to maximize Y. So 760 will match it here. Remember that we represented X by dozen A and Y by dozen B. So meaning for X to maximize dozen A cake, we'll need 5 for X, and we'll need 22 for what? Y. That's all. So to maximize, sorry, let me clean the top side. So we got to our maximum profit. Our maximum profit is 760. So we got a 760 from a coordinate named C. So with the C, it was 522. So the baker, remember this is X, this is Y. So the baker would maximize so this is 5, this is 22. So the baker would maximize profits from 5 units of dozen A cake and 22 units of dozen B cake. So that's how we do it. Once you get the maximum profit, match the maximum profit to its coordinates. So it was a C. So we have 5 and 22. So they are saying how many of dozen A, which is X, and how many of dozen B, which is Y, would maximize profit. Since we know the maximum profit is 760, we match it here. X is 5, Y is 22. So to maximize dozen A cake, we will need 5. To maximize dozen B cake, we would need what? 22. So the baker would maximize profit from 5 units of dozen A cake and 22 units of dozen B cake. So this is how we solve the first question. So if you have any question, you can drop it at the comment section. I would reply. I'm very good at responding with respect to questions being asked pertaining to a video I post. So this is how we solve linear programming. So let me just do a short recap. With the identifying the feasible, the admissible region, if the question is using maximize, it forms here because everything is below, so it forms here. But if the question is using minimize, it means what? Greater than, so everything forms at the outskirt of the diagram or the outside. So minimize forms here, then maximize forms within the shape. That's basically the difference. So I'll try and solve. So this is a question with maximize. I'll try and solve another one with what? Minimize. So for now, this is the first solution for the question we just solved.